When you're driving down the road, have you ever really thought about what's underneath the asphalt? It's definitely not just a layer of blacktop sitting on some dirt. No way. It's actually this really complex, carefully engineered system of layers, and each one has a super specific job. So today we're going to break it all down, layer by layer, and look at the granular materials that really form the backbone of our roads. All right, let's dig in.
So let's get right to it. The big question, why go to all this trouble? Why can't we just slap some pavement directly onto the ground? Well, the answer in a word is strength. The plain old ground itself, it's almost never strong enough to handle the constant pounding of traffic. You see, everything, and I mean absolutely everything in road construction depends on the quality of the natural ground it's built on. In the world of engineering, we call this the subgrade. The best way to think about it is like the foundation of a house, right? If that foundation is weak or shaky, the whole house is in trouble. It's the exact same for a road. And that gets us to the #1 problem that engineers have to solve. The natural ground, well, it's totally unpredictable. It can be soft, it can be wet, it can be unstable. Basically, a terrible base for a multi-million-dollar road that's supposed to last for decades.
Now, to put a real number on this, engineers use a measurement called the California Bearing Ratio, or CBR for short. And here's the magic number, the critical threshold. If that CBR number is less than 5%, the ground is officially too weak. You just cannot build a lasting road on that without fixing the foundation first, period.
So what do you do when you have a weak foundation? Well, you build a better one right on top of it. And this first absolutely crucial layer is called capping.
And here it is, Type A capping material. Now listen, its one and only job is to create a stable, working platform over that weak, mushy subgrade. And pay close attention to that last part. It is not, I repeat, not considered part of the structural pavement itself. It's purely for improving the foundation. That's it.
And would you look at the impact of this one layer? We've gone from a subgrade with a CBR of less than 5 all the way up to a minimum of 15. Just like that, our foundation is solid. Now we have something we can actually build on.
Okay, so our foundation is stable, we've got a solid platform to work on. Now we can finally start building the actual road structure. So let's move on up to the sub-base layers and see how this thing gets built. The very first structural layer to go down is what's called Class 4 crushed rock. This is our lower subbase. It sits directly on top of that capping layer we just laid, and its main job is to start distributing the load from all the traffic that's going to be up top. And whoa, look at that jump in strength. We've gone from the capping CBR of 15 all the way up to a minimum of 45. You see the pattern here? Every single layer we add is significantly stronger than the one below it. Right on top of the Class 4, we put our upper sub-base layer, Class 3 crushed rock. Now this is a higher quality material, and it kind of acts like a bridge, spreading the load out even further and getting everything ready for the premium, heavy-duty layer that's coming next. And you guessed it, the strength goes up again. We're now at a minimum CBR of 60. You can really start to see the logic, right? We're building this pyramid of strength, with each layer getting more and more robust as we go up.
All right, we've built the foundation, we've built the support structure. Now it is time for the main event, the base course. This is the layer that does the real heavy lifting.
And here it is, the top shelf stuff, Class 2 crushed rock. This is the highest quality granular material in the entire pavement structure. It's incredibly dense, incredibly strong, and it's designed to take the direct, punishing force of trucks and cars right before that force hits the asphalt itself.
And this brings us all the way up to a California Bearing Ratio of at least 80. This is the very top of our granular pyramid, providing the ultimate, most robust support for the road surface. It's the last line of defense.
Okay, so we've looked at each layer one by one. Now, let's zoom out and put it all together. Let's see how this full system actually works together.
And here it is, all laid out nice and neat. We start with that Type A carping just to fix the weak ground. Then we build our pyramid of strength, Class 4, then Class 3, and finally, the super strong Class 2 base course at the top. It's just a logical, powerful progression from bottom to top.
You know, this is a really common question, and it gets right to the heart of why these materials are different. It's really easy to just look at the numbers and think, oh, Type A is just a bad version of the other classes. But that's absolutely not the case.
And the official engineering standards? Well, they could not be more clear on this point. This is the definitive answer, right from the source. A capping layer is simply not equivalent to any class of crushed rock. Its purpose is completely different.
And this, right here,
This is the most important thing to remember. The crushed rock classes 4, 3, and 2, those are structural. They are the skeleton of the road. Type A capping is foundational. It's only there to improve the ground before you even start building the structure. Two different materials, two completely different jobs.
So here it is, our final sequence from the ground up. We start with that weak subgrade, we fix it with Type A capping, we build our strong structural layers with Class 4, Class 3, and Class 2, and then, and only then, do we add the surfacing, the asphalt or seal that you and I actually drive on.
Now, for those of you who want to get into the weeds, this table shows all the technical specs. You can just pause here and check it out. But notice how things like the maximum particle size get smaller as you go up the layers, and the requirements for durability get way stricter, especially for that premium Class 2 rock.
So, the next time you're driving past a road construction site and you see all those different piles of gravel and rock, you'll know exactly what you're looking at. It's not just a messy pile of dirt, it's a carefully engineered system built for strength from the ground all the way up.